Today we will solve the pool of promises task on LeetCode. The task description is a bit long, so let's jump directly to the examples. Our function takes two arguments. The first one is an array of functions, where each function returns a promise with a timeout. The second argument is size of our pool. The promises will never reject, so we don't need to handle errors. For better understanding, let's visualize the task, where we have a pool with size limit. Let's say n will be 2. We have 3 promises, and each promise has a set timeout. Because limit is 2, we enter the first 2 promises. And as soon as any of these promises are executed, we enter a new one. The output from LeetCode is just for visualization. It's not the actual output you should return. You just need to execute your promises in specific order. As you can see, the first promise will be executed in 300 milliseconds, the second one in 400, and the third one in 500 milliseconds. Okay, now let's try to solve this task. First, I will use Promise.all. Promise.all waits for all promises in the array to resolve and then returns a new promise. Because we have a limit on how many promises we can resolve at once, I will take only the first n functions using slice, where 0 is the start position and n is the end. The next step is to use map to all the helper function. For each promise, once it resolves, the helper function will execute and the promise will be resolved. Now let's create a helper function that will be executed for each promise. The most important part is to check if the current limit is less than the length of the function's array. This means we have more promises to resolve. In the if statement, we will use n as the index for the functions we need to run. We also increment n after each execution and add our helper function in the then method, just like we did before. That's all we need to do. As you can see, we successfully passed all test cases. Now let's submit the solution. Let's wait for a second, and as you can see, we successfully submitted the solution. About the complexity, you can correct me if I am wrong. It's a bit tricky, but I will try. The space complexity will be O(m) plus n, where m is the total number of tasks and n is the number of tasks that can run at the same time. Time complexity will be O(m), where m is the total number of our promises in the functions array. That's all for today's video. See you next time.